Hello and welcome. In this video, we'll begin our discussion of how we can implement simple linear regression using R. As part of our discussion today, we'll be discussing how we can do a basic scatter plot, how we can fit and test correlation, and how we can fit our simple linear regression line using R. So let's go on and get started. I'm going to be using the marketing data example where we looked at the relationship between marketing and profit, at least for this first video. So for me, I'm going to go on and enter this data set. As always, you can go on and pause the data and enter it yourself, or pause the video and enter the data yourself if you're interested. 9.5, 6.0, 9.5, 9.7. Part of me wonders if I should just do this off screen, but I don't know. I think it's kind of useful. Sometimes I feel like when we teach, we only show the sexy stuff. We only show the parts where everything looks pretty and is all well done. And that's well and good. I mean, we don't want to waste your time watching stuff that doesn't work. On the other hand, sometimes it's just useful to realize that it takes a little bit of time to type stuff in and that can be wrong too. All right, so for me, this is what I've got, my marketing and my profit data. So what I'm going to do here is I'm going to show two ways that we can plot the data. And the first is by giving it an X and a Y axis. So remember, our independent variable tends to be on the X axis and our dependent variable tends to be on that Y axis. So in this case, my independent variable is marketing. My dependent variable is profit. And so I would give it both of these, and I would get this plot. And that looks like the plot we had in our, roughly like the plot we had in our graph. So that's good. Yay. Another way you can do this using the formula notation that we used in ANOVA is you give it the dependent variable, profit, and then a squiggle, and then your independent variable, marketing. And this works too. And remember that squiggle notation is something that we've talked about before in our ANOVA, and we'll talk about it later on as well in regression. All right, that's our scatter plot. You really just have to have the data, and then if you just do a plot and indicate which values correspond to which axis, the plot gets put together really pretty quickly. All right, well, let's move on to doing our correlation. So I'm going to just make a note that I'm starting that here. We'll talk about how we do it by hand first before we talk about the built-in functions. And for me, rather than retyping marketing and profit over and over and over again, I'm going to use a little bit of a shorthand notation. I'm going to use extremely shorthand notation, actually. I'm just going to use X in place of marketing. Now, you should realize everything I write from here on out, every place I put X, I could have just put marketing to represent that data set. The only reason I'm doing X is because X is a lot shorter to type than marketing. So a lot of my work is going to be a lot shorter to type out and maybe less long and confusing if I just use X instead of marketing. But that's the only reason I'm doing this here. So feel free, if it's easier to understand for you, to in place of X, just put marketing for each of the things we're about to do. Similarly, instead of profit, I'm just going to do Y. And I need my X bar, that is the mean of X, or mean of marketing, and Y bar, that is the mean of profit, to do my future calculation. So I'm going to make sure all of this is run. You can highlight it and hit Control Enter to copy and paste it over to the side. You can highlight it and copy and then move it to the right and paste. That works too. You know, whatever works for you. All right, so thinking about my correlation coefficient, I have the sum of X minus X bar quantity, or excuse me, X minus X bar times Y minus Y bar, sum of all that, over the square root of the sum of X minus X bar squared, plus, or times the square root, or times just the sum of Y minus Y bar squared. Look at your equation. That's what we're trying to build here. So think about what our goal is. First of all, I have X minus X bar. I want to wrap this in parentheses. This is going to be a whole bunch of numbers because it's for each of the X values, their X value minus X bar. And I want to multiply this by Y minus Y bar. Again, for x minus x bar, it's a bunch of numbers. Y minus y bar is also a bunch of numbers. And this is both of those numbers multiplied by each other. For this particular value, I wanted the sum of x minus x bar times y minus y bar. And this is the numerator of my correlation. Now I could save this as a variable, but I'm just going to end up copying and pasting this when I put these things together. For the denominator, I wanted x minus x bar squared, and notice that I'm putting that in parentheses, and then I wanted the sum of that quantity, sum of x minus x bar, quantity squared. So this is all of the x minus the x bars, and then I raised them all to the second power. So all of these values actually raised to the second power, and then I just added them all up. And then I wanted to do that for y minus y bar, sum of y minus y bar squared. And then I wanted to take the square root of all of that. I wanted to multiply these together and take the square root. So the square root, and then I'm just copy and paste for the x bar, sum of x minus x bar, and then times, and then the sum of y minus y bar. And this is my denominator. As you can see, I tend to not write just the long line by itself. Sometimes I do, but sometimes it's nice to build up the pieces to really get, all right, here's the first piece, here's the second piece, and then I can just copy and paste them when it comes time to multiply them together. For instance, here, it's nice that I track the numerator and denominator, because for the correlation coefficient, I'm going to take this, I'm going to have the numerator. I'll go on and make my open and close parentheses. They're not needed here. But it is nice to just have, all right, everything in that first parentheses, that's the numerator. Everything in that second parentheses, that's the denominator. And this is my correlation coefficient, hopefully. All right, so I'm going to go on and save all of this as R, my correlation. And now I can just use R, my correlation, whenever I need to use the correlation in something. For my test statistic, I need the sample size. So remember, the sample size is just how many numbers I have. So I'll do the length of marketing, or X. How many marketing values do I have? In this case, there's 7 marketing values. And then my test statistic is R, the correlation that I just found, times the square root of n minus 2. Divided by the square root of 1 minus r squared. So this is just my formula, and I'm going to copy and paste this as my test statistic and save that value. And again, you can, as before, copy and paste numbers as much as you want. If you prefer using numbers to variables, that works just fine. From here, this is distributed as a t-distribution. So we can go on and find this if we want to. For the critical value, my degrees of freedom is n minus 2. So I'm gonna just type in my alpha and degrees of freedom. So alpha is 0.10 in this case. If I were doing a two-tailed test, I would do 0.10 over 2. In this case, I think we did a one-tailed test looking for a positive relationship between these things. The degrees of freedom is just n minus 2, the sample size minus 2, or 5. And then because we're looking for a positive direction, we do lower tail equals false. So this is my cutoff for my critical value. For my p-value, I use pt, give it my test statistic. Degrees of freedom stays in minus 2. And I still use the lower tail equals false because I'm only looking in that top tail direction. That's all I'm looking for. So I don't have to do the times 2, and I don't have to look in both directions. I already know that this is an upper tailed test, a greater than test. So that's my p-value. Cool. All right. Well, we're moving pretty quick here. We're already at the built-in tests. Again, the one everybody comes for, I'm sure. These are so useful. And again, this is, when I do this, I rarely do the by hand work unless something just seems very weird and I need to go investigate it. When I do this, I do the built-in tests. So for me, I would do core, and because if I'm doing built-in, I would just hand it my original values, Could I give it X and Y? Absolutely. Again, they're the identical thing. But if I'm not doing the handwork, I don't need to retype X and Y a ton. I would just give this the actual values I'm talking about, the marketing profit. And I can double check my work here, which I'm actually excited to do. I didn't double check this before I recorded this video. But yes, it looks like the correlation is what we calculated in our correlation calculation. So that's good. It's always awkward when we record a video and that's not the case. Of course, I mentioned the rough, my hand typing in answers or data and stuff like that. But the real rough ones you don't see, and that's where I just completely mess something up. I kind of hide those a little bit, re-record them. Fortunately, it doesn't happen too often, but my goodness, when it does, I'm not legally allowed to repeat some of the words that I say in that case. All right, so for a greater than test, I get my do the core.test command. So that's our new thing today. This is how we do a correlation test. I give it my two variables, and then I specify which alternative I want. So remember, this is order important. So I want marketing greater than profit. And if I wanted that to be backwards, I would, say marketing's less than profit, or I'd switch the order. Profit goes before, and that would say profit is greater than marketing. So be careful. The order of your variables here and the alternative, those do play off of each other. So just think about it for a second. The test statistic matches what I calculated earlier, 1.9219. Thank goodness. The degrees of freedom is the same. P-value also looks the same. Thank goodness. So everything looks like it's functioning well here. I'll mention, we talked about the confidence interval. Remember to not interpret R as confidence intervals when we do one-tailed test in R. So if I wanted to interpret the confidence interval, I would either just remove the whole alternative thing to activate its default value, which is two-sided, or I would manually write two-sided, and that would give me a reasonable confidence interval. As we've discussed in the lecture notes, the confidence intervals are actually kind of a pain to put together for correlation, so we didn't do it. In R, though, again, it's just kind of built in. It's a default output. So this is just really, really nice. You'd interpret this the same way as you would other confidence intervals. Again, we didn't build it in this class because the by hand stuff is just too complicated to worry about. And it's not actually that complicated, but it's beyond our scope. It is nice though that, again, in software, it's just really, really, really easy to use, and we've already talked about the interpretations, so it's pretty straightforward. All right, so let's talk about this coefficient of determination guy. We've got the correlation here. I've already written the correlation out, R. Again, everything's matching, so you can use whichever of these calculations of correlation you want. And the coefficient of determination is just R squared. R raised to the second power. That's it. Ta-da! This was an indicate that 42% of the variability in profit is shared by marketing, and simultaneously 42% of the variability in marketing is shared by profit. So it doesn't indicate which direction that goes. Remember, if we want direction indication, that is, if we want causation, not correlation, we have to implement a study design and interpret it in the context of the broader study design. So it takes a little bit more work. All right, so that's our correlation. Let's go on and keep moving. So we're going to keep moving into the basic SLR model. And so we're not going to get into inference in this video. We'll get into that in a future video. But in this video, we're going to talk about how we can build the basic SLR model and just kind of build that out. All right, so I'm going to take my X and Y, and remember, a lot of the quantities here are going to be the same as above. So for my, like for my B1, remember that is my sum of, that numerator is the same, and actually the denominator is just this part. I could just copy and paste these. I won't, but I could just copy and paste these. So well, maybe I should. You probably should, so you don't have to retype all this. X bar times Y minus Y bar. That's the numerator still. And then the denominator is just sum of X minus X bar quantity squared. Note that I'm squaring it before I'm taking the sum of it for this particular quantity. And B1 is just the ratio of these two things. I just take the first one, and I'll again pre-build my fraction when I make big fractions. Put the first one on the top side and put the second one on the bottom side. And this is my B1. So I'll go in and save that as B1. Note that this is somewhat easy simply because we already did a lot of the building components up top when we built the correlation, and B1 and the correlation share virtually the same construction, except the denominator doesn't have this part in B1 and the denominator isn't the square root. It's just the sum of x minus x bar quantity squared. Pretty cool. So that's B1. That was pretty quick. Let's do B0. So y bar minus x bar times B1. So remember, nope, I need to save it. Remember, we need to find B1 before we can find B0. And once we have it, the equation for B0 is pretty quick. So I'm going to just go on and save that one as B0. So quickly, we can graph the fit line. So we had the plot, plot of x and y here. And, you know, we can add some labels here. X lab stands for X label. This was marketing. And Y lab stands for Y label. This was profit. And from here, we can do the AB line command. A is the intercept, B0. And B is the slope, B1. So we give AB line an A and a B. And this draws a line up here. Oh, and you can see R tried to draw the line, but I mistyped it. I drew the line in the wrong place. So I can do B0, and you'll see it adds a line. Note that this adds lines, so if I want to redo this, I would redraw the whole plot and then add the correct line. So that's kind of silly, but shows you, hey, if you mess it up, R is just going to put the line out there for you. It's not going to guarantee that it's right. Your math up here guarantees that the intercept and slope is right. So comparing that line to this line, we see this line looks a lot better. This is our best fit line for this data set. All right, and y'all, that's it. That's the simple linear regression model. Ta-da! Again, uses a lot of components from the correlation, but even that was pretty straightforward. Simple linear regression, the basic model, is also pretty straightforward. When we get into inference, that'll get a little more interesting, but the simple linear regression isn't too bad. All right, let's talk about how we do this with the built-in functions. So for the built-in function, the command in R is going to be LM. That stands for linear model. I give it my dependent variable and then the squiggle and the independent variable. And again, typically I'm going to give it profit, squiggle, marketing if I'm doing the built-in command, because I'm not going to have X and Y, because I'm not going to need the shorthand to do all the short calculations. In fact, if I'm not needing the shorthand to do all the typing here, I prefer to leave it in its original form so that I can track what variables am I doing my calculation with. Oh yeah, I'm doing it with profit and marketing, and that makes sense. You'll note here, and I can run that and give us our B0 and B1. These values match, but it's worth noting the notation. The intercept is pretty straightforward in terms of how it denotes it, but for the slope, it denotes it as the name of the variable, marketing. And when I did this with X, I'm just pressing up to get access to my previous commands. When I gave it the letter X, or the variable X for my independent variable, it labeled the slope as X. Ultimately, what this is doing is preparing us for a case where we're going to have multiple slopes for multiple independent variables. In R, it's built for that more generic case. And so for here, what we're seeing is this is the slope associated with the independent variable marketing. Now, when we just have one independent variable, that makes a ton of sense because we're only dealing with one slope. And so this is just the slope. But again, looking ahead just a bit, when we get to a place where we're dealing with multiple independent variables, then we're going to need to distinguish between, well, which is the slope associated with that independent variable, which is the slope associated with this independent variable. So that's what R is doing here. All right, I'm going to go on and save this. I'll call it SLR underscore mod, and I'll just save this named one. All right. And you know, actually that SLR mod, that gives us our basic fit. We'll play with this a little bit more as we go through this lecture set implementing simple linear regression in R. But one thing maybe we can do is talk about how we can do the graph. So for the plot, maybe I'll do X equals marketing and Y equals profit if I were doing the built-in command to do the plot. Again, that remakes my plot down here. I could add some axes labels if I wanted to, clean that up a little bit. But then once I have the simple linear regression model fit, I don't have to give it my slope and intercept by hand. I can just give it the simple linear regression model variable. Again, the variable SLR underscore mod that I'm using to store the simple linear regression results. And if I give that to the AB line, R knows it should plot a regression line on my scatter plot. So I can see this line of best fit on the scatter plot. All right, team. Well, this has been a relatively quick in terms of some of our other video discussing how we can do scatter plots in R, how we can do some basic correlation in R, along with testing not confidence intervals, but critical values, p-values, and the built-in tests, which do give us confidence intervals, but we won't use those for this course. And then how we can do the basic simple linear regression model, both by hand and using the built-in functions, as well as, just for fun, how we can put the best fit regression line on a scatter plot. All right, team. Well, thanks for sticking with me, and I will look forward to catching you in the next one.